Hello friends, welcome to ECECASTS. Today we will solve a question from Basic Circuit Theory. This question appeared in GATE 2013. It is a 2 marks question. The question is the current Is in amperes in the voltage source, which is this, and voltage source Vs in volts across the current source, which is this, respectively are. In other words, we need to calculate the current Is and the voltage source Vs from this circuit given. So friends, this is the original circuit diagram. I have added a couple of points for our easy reference. First, I have marked this node as A, the current flowing in this direction as I2, the voltage drop across 2 ohm resistor as V2, that across 1 ohm resistor as V1. This is just for your easy reference. Friends, our aim is to calculate Is and Vs. To do so, we first calculate V1. So friends, now look onto this 1 ohm resistor. We see that these two circuits are in parallel. That is, the 1 ohm resistor is in parallel with the 10 volt supply. As we know that when two circuits are connected in parallel, the voltage drop across the two circuits should be same. Therefore, V1 should be equal to this 10 volt supply. So V1 is equal to 10 volts. Next we calculate I1. I1 is equal to V1 divided by 1 ohm, which is 10 by 1, that is 10 amperes. Next we calculate V2. V2 is the voltage drop across 2 ohm. When you look at the circuit, you will see that this 2 ohm resistor is connected in parallel with the 10 volt supply. So therefore, the voltage drop across 2 ohm should also be equal to 10 volt. So V2 is equal to 10 volt. Now that we have V2, we can easily calculate I2. I2 is nothing but V2 divided by 2 ohm, which is 10 by 2, which gives us 5 amperes. So friends, we have solved I1 and I2. We move on to solving Is. To do so, we apply KCL at node 1. We get minus 2 amperes, which is this, plus Is plus I2 plus I1 equal to 0. Is therefore becomes 2 minus I2 minus I1. We replace the values of I2 and I1 in this equation. So we get minus 13 ampere as Is. To calculate Vs, we need to apply KVL in this left loop. To frame the KVL equation, we need to know the voltage drop at node A. When you look at the circuit, you will see node A is directly connected to this 10 volt supply. Therefore, the voltage at node A is also equal to 10 volt. Now we frame the KVL equation. Applying KVL, we get Vs minus Va minus this 10 volt supply is equal to 0. We replace the value of Va, so we get Vs minus 10 is equal to 0. This gives Vs is equal to 20 volt. So we are getting Is as minus 13 ampere and Vs as 20 volt. So we move on to the slide which has the options. So friends, from the 4 options that we have, we see option D has Is as minus 13 and Vs as 20 volt. So our answer is option D. Friends, thank you so much for watching this video at ECECASTS. Please kindly subscribe for similar videos.